The purpose of this experiment is to determine the unknown concentrations, the pH, and the pOH of 3 different acids by titration. Titration is the controlled addition and measurement of the amount of a solution of known concentration required to react completely with a measured amount of a solution of unknown concentration. Since acids and bases react, the progressive addition of a base with a known concentration to an acid with an unknown concentration, or vice versa, can be used to compare the concentrations in order to determine the chemically equivalent amounts of the acid and base. In a titration, successive additions of an aqueous base, whose concentration is known, are made to a measured volume of an aqueous acid, whose concentration is unknown. As the base is added, the pH changes from a lower numerical value to a higher one, occurring slowly at first, then rapidly through the equivalence point, and slowly again, as the graph here shows. See, we have the acid right here, and it's clear in the presence of the indicator phenolphthalein. Then you see it goes quickly up to the equivalence point. Here the phenolphthalein is light pink at the equivalence point. Then it slowly gets around to the end point, where phenolphthalein is dark pink. The equivalence point is the point at which the 2 solutions used in a titration are present in chemically equivalent amounts. A person knows when the equivalence point has been reached because the indicator in the mixture will turn the color it would show in a neutral solution. Once the endpoint is reached, the endpoint of the titration is the point at which the indicator changes color to the color it would show in a basic solution, like up here. Once the endpoint is reached, a person can find the volume of the base and the acid used in the titration. Using a series of dimensional analysis problems, the molarity of the unknown solution can be found using the volumes, concentration of base, and mole ratios from the balanced neutralization equation.
First, each burette was filled with the appropriate amount of acid. 9 milliliters of acid were poured out into the flask. Once the acid had been added and 3 drops of phenolphthalein added to that, the base was added slowly in incremental amounts until the equivalence point was reached. Measurements were then taken of the volumes of acid and base used, and later calculations were done to find the acid's molarity.
Oh, we're getting close. We're getting really close now. All right, 1, 2, 3, 4, 5, 6, 7. Oh, it's fading. Fading fast. Actually, I think this might be perfect. Yeah. This is perfect.
What we have versus what we need to find.
So a known quantity already is the molarity of the base. Now we have to find the average moles of the base. You can do that by plugging in the molarity and the average liters of solution of the base. When the average moles of the base is found, you can use that to find the moles of the acid by using the balanced chemical equation. To find the pOH, then the concentrations of H3O plus and hydroxide ions. Basically use the general equations. So if we find the pOH you have to do negative log of the hydroxide concentration. To find the concentration of hydronium, you have to do 10 to the negative pH.